Hello test takers, welcome back to Exam Prep Solutions, and today we're taking a look at a transportation problem. We're going over stopping sight distance. We have a free guide called 5 Steps to Solving Any FE Exam Problem. You can find that guide for free in the description box down below. Just tell us where to send it. Anyways, let's get into this problem here. I suggest going ahead, trying to solve this problem first, selecting an answer, and then taking a look at the solution. You can only get better at answering these problems by putting in the work and putting in the practice. Anyways, I'm going to go into my solution now. Determine the stopping sight distance required for the vehicle with the following characteristics. It's got a velocity of 75 feet per second, a downhill grade of 4%, reaction time of 0.75 seconds, and a deceleration of 15 feet per second. So if I'm going to start with the solution here, we have the stopping sight distance equation, which is 1.47 VT plus this whole mess of terms here, v squared over 30 times a over 32.2 plus or minus g. Okay, so that's our whole setup here. Now let's get this first term to start off with. Now this 1.47 factor is actually a factor to convert velocity 75 feet per second into miles per hour. So keep that in mind. But this top term, this top v squared term, needs to be converted to miles per hour, or needs to be converted to miles per hour, I should say. So you can use the 1.47 factor, that works too. But I just want to show you that 75 feet per second can convert into miles per hour. We go 75 divided by 5,280. That equals 0.0142 times by 60 times by 60 equals 51.12 miles per hour. So we're going to use that for our first term. Times it by t, which is the driver reaction time. We're going to go with 0.75 seconds in this case. And now I'm going to get the answer for that. So that's going to equal 38.34. Now let's find the second term here. We need miles per hour once again, so 51.12 squared. That top term is going to be close to 2,600. And now let's get this bottom term here. So A, the deceleration is 15 feet per second divided by 32.2 plus or minus g. Now remember, it's a downhill grade, so we're going to be using a negative here in this case. So 0.4658 minus 0.04 equals 0.4258, and then we're going to multiply that number by 30. That's what the bottom term has there. 12.774. So we're going to take 2613.25, and then we're going to divide it by the 12.774. And that equals 204.5757. I'm going to 204.5, I'll just say 6 plus 38.34. So this is a calculation dense problem here. We get about 242.94. I'm going to go with the closest answer here being answer C, 230 feet. However, this is actually confusing, right? So determine the stopping sight distance required. We wouldn't want to put 230 feet. That's not going to be enough, so we need to go to the next greatest. The answer is going to be D. 275 feet in this case would be a safe, accurate assumption for this problem. So the key is making sure we have this mile per hour term set up correctly, that we're doing our conversions appropriately, and you're being careful with your calculations in this case. So I hope that was helpful. If you have a question, leave it in a comment down below, or if you have a kind of problem you'd like us to cover, leave that in a comment as well. Thank you so much for watching. I'll see you guys next time.